Hello students, welcome to the video lectures of software engineering. So today we are going to talk about design engineering. So design engineering is a core activity in software engineering that focuses on creating a blueprint or model of the software to be developed. So this model acts as a foundation for construction. So construction is nothing but the implementation of our project what we got. Okay, so that is nothing but coding and implementation. Okay, so what it is trying to tell you is, so once we get all sort of the requirement analysis is done, okay, then we move on to this particular stage, that is to design. So designing is nothing but to have a implementation that is being done. Either it might be a coding or implementation, we say. Okay, so finally it creates you a software model, so wherein the design engineering have, one second, the design engineering have some set of principles. So this have some set of principles and concepts and practices which leads you to have a high quality software product or a system. Okay, so this is what is design engineering says. So then what are the goals of design engineering? Okay, so the design engineering have a set of goals where to it tries to create a model which tries to exhibit features like firmness, commodity, and delight. What are these? So firmness is the reliability, we can say. Okay, the reliability or the amount of correctness that exists in the model. Okay, then commodity is the next goal. It is nothing but how much it is useful. Okay, usefulness, we can say, or usefulness, and sometimes it can be functionality also, we can say. Okay, functionality, usefulness and functionality falls under commodity. Delight is to have user satisfaction, and quality. So these are all the goals of design engineering. Clear? So design engineering is a core activity, okay, in software engineering, which focuses on creating a blueprint or model of the software to be developed. This acts as a foundation for construction. Construction means coding and implementation. Clear, students? Right. So next we have design within the context of software engineering. So what it is showing, you can see the translating the requirement model to design model. Okay, now this design model, it produces several designs followed by, you can see in the diagram where you see the data class design, an architectural design, an interface design, a component design, and a deployment design, which are given in the diagram here. You can see data class design, architectural design, interface design, component level design. Okay, so here what does each represent? Okay, you can see in the diagram there are a couple of things which are being shown. So what does these things represents? Okay, so let us try to understand now. So first of all, you can see here it is mentioned the data are class design. The data class design, first one. Okay, this transforms the analysis class model into design class realizations and data structures. Then the architectural design will define you the relationship between major structural elements of software. And coming to the interface design will describe you how the software should communicate with the systems that interoperate with it. Then the component level, this will, this component level design will transform the structural elements of the software architecture into a procedural description of software components. Okay, students. So this is how the translating the requirements model to design model. Okay, so here you can see the scenario based elements, use cases, use case diagram, activity diagram, swimlane diagram, flow oriented DFDs and CFD processing narratives. Here class diagram, analysis package, CRC model for collaboration diagrams, in behavior state diagrams, sequence diagrams. Okay, these are all fall under your analysis models. From here you can see the design model. Then the design process in software engineering. So the design process involves several stages. First one is high level design. Next is low level design. Next is design refinement. So what are these things represent? So when I say high level design, so this is kind of architecture we get here. Okay, means what does architecture have in general? So where it determines the overall system structure. and its components. When I say components, please remember these are the modules. Then next is low level design, where you will have some kind of detailed design here. So what it shows you? So it will specifies the detailed functioning and interaction of the system components. Then we have design refinement. This will revise and refine the design. Okay. So why it should revise and refine? Just to ensure it will meet the system requirements. Okay. Let me specify that point also. To ensure it meets the system requirements. Okay. So these are all various stages in the design process. Then we have design quality factors. So design quality factors. So those are, you can see, correctness. First one is correctness. Next is maintainability. Next is efficiency. Then it's scalability. Then it's usability. So these are all the design quality factors we call. Okay. So let us try to understand these things first. Okay. So what is the first one? Correctness is. Okay. So the correctness speaks. Let me write here. Okay. The design must meet the requirements. Okay. And not only meeting the requirements, since we are saying this as correctness, it should be error free also. Clear? Then we talk about maintainability, where the design should be modular. So why it should be modular? So whenever we find some kind of change, let me write, easy to make the changes. Okay, whenever you find some kind of change that has to be made in the future, so you can just do whatever you want. That is what the feature quality factor maintainability speaks about. Then about efficiency. Efficiency is to make the product to work efficiently, right? Work efficiently. So of course, one point what you have to remember is, so we need try to make some minimal resources that are to be drained here. Then it's scalability. So to meet the future needs is this the term scalability speaks. That means, let us say you have designed a particular software which can handle, let us say, 1,000 people. Okay, so let us say this is the use of this has been increased to some 10,000 people down the line after 6 months. Then you should be able to scale it up. Okay, so you should be able to scale up. So that is what scalability speaks. So it should be able to handle the increased loads. Then the final one is usability, where the design should facilitate ease of use for users and developers. Okay, this is usability says. Next, there are quality attributes. We call them as FURPS. So what is FURPS? So Hewlett Packard developed a set of software quality attributes given by the acronym that is FURPS. Okay, so the FURPS is nothing but the following things. You can see functionality. F stands for functionality, U stands for usability, and R stands for reliability, P stands for performance, S stands for supportability. So what are these things? Okay, so when I say functionality, so it is assessed by evaluating the feature set and capabilities of the program. And when I say usability, it is assessed by considering human factors, overall aesthetics like consistency and documentation and everything. And when I say reliability, so reliability is evaluated by measuring the frequency and severity of failure. Not only that, but also to the ability to recover also calculated. That is, we say MTTF, right? Mean time to failure and predictability of the program, all these things. Then it's a P for performance, where it is measured by processing speed, response time, and resource consumption. Then supportability, it combines the ability to extend the program, adaptability, serviceability, which represent maintainability of the project. Combining all these things, we say it as FURPS. This is developed by Hewlett Packard, that is HP company. So these qualities or the attributes must be considered as soon as the design commences. Okay. But please remember, these should be considered before the design commences, but not after the design is complete. Okay. I mean to say before the construction has begun. Then we have design concepts, abstraction, architecture. Abstraction, architecture, modularity, information hiding, functional independence, refinement, refactoring, and design classes. Okay. So what are these design concepts? We'll see. Okay, one by one. First one is abstraction. So we know what is abstraction is already, but coming to these design concepts, abstraction speaks, which tries to simplifies problems at multiple levels. Okay. So like data abstraction, where it describes the data, right, in such a way. Then it's architecture. So architecture will define the structure, interaction, and data. We have seen about the architecture in the previous lecture as well. Then, so let us say, like the structural frameworks or some function models, all these can be represented for this particular architecture. Then it's modularity. So where we break systems into manageable modules. Okay, like which makes us to have kind of ease of planning or testing and maintenance. Then it's information hiding. So where it hides the internal module details. So why we need to do this? Just to minimize the error propagation. Okay. Then it's functional independence. Functional independence is we have a couple of modules, right? So we try to minimize the responsibility, we can tell. Okay, responsibility. So we try to minimize the responsibility such that there will be a minimal interaction. Okay, that means let us say there is one module, or that module is having only a single responsibility. Okay, so then the refinement. So refinement is it's the top-down strategy to elaborate procedures step by step. Mhm. Then it's refactoring. What is refactoring? Which improves the structure without affecting the functionality. Then design classes. What does it do? The design classes will translate analysis classes into implementable units. These are design classes, like UI classes, business domain classes, process classes. All these fall under this design classes. Okay. So these are all the design concepts. Okay. Abstraction, architecture, modularity, information hiding, functional independence, refinement, refactoring, design classes. So then characteristics of a well-designed, characteristics of a well-formed design class. So first one is complete and sufficient. Second one is primitiveness. Third one is high cohesion. Then it's a low coupling. Okay. So what is complete and sufficient? So complete and sufficient is nothing but like it only needs methods and attributes. Okay. And when I say primitiveness, it's kind of one module, one responsibility, or one method, one responsibility. Then what is high cohesion? So high cohesion is having small and focused class. So then what is low coupling? It is the minimal dependency. Okay. So these are all the characteristics of well-formed design class. Okay, students. So hope you understood. Thank you.